In this video, you and I get to discuss, implement, and verify MAC Authentication Bypass using the ICE server. We also get to do some troubleshooting as part of this video. Let's begin. I'd like you to imagine that you and I want to put an IP-based camera in the lobby of our building. So we get an Ethernet cable run to the location where the camera is going to be, and then we physically have it mounted. Now, one of the challenges of having this connection into the lobby is that what if somebody disconnects the camera and they plug in their own computer? Are they going to have access to the network? And hopefully, this connection that's intended for a camera will only be used by that camera. There are some security controls that you and I can implement to help make sure that no one else hijacks that port and starts using it. Number one, hopefully we have somebody in the lobby that's looking in the vicinity, like a security guard or something else, that's going to notice if somebody's on a ladder disconnecting the camera and plugging in their laptop. And that would be an example of a physical control, having people looking there, observing to prevent that from happening. And that could act as a deterrent. However, from a technical control perspective, what we could do on the switch is we could go ahead and use port security. And in port security, we could tell this port that only one MAC address is allowed, and we could hard code it. So we could hard code the MAC address that's being used by the camera so that only that one MAC address would be able to go through. However, another option, if we wanted to use it, is to use MAC Authentication Bypass and have this switch port controlled by 802.1x. And on the ICE server, we could create an entity for our endpoint. So here's our camera. So let's imagine that our MAC address for this camera is these 12 hexadecimal characters, which are representing the 48-bit MAC address. We could create an entry on the ICE server with that MAC address, identifying that MAC address as one of our endpoints. And then on the switch, we could say, you know what, instead of just using .1x authentication, let's also go ahead and enable MAB, MAC Authentication Bypass. So we can enable both of them, and we can also specify the order that we want them enabled in. So when the camera connects, when there's link, it could go through .1x, and then when that times out, it could go ahead and try MAC Authentication Bypass. And at that point, during MAB, the actual MAC address is going to be submitted over to the ICE server, and if the ICE server has an entry for that MAC address, it's going to be 2 thumbs up, and that port is now considered authenticated. So the ICE server can go ahead and tell the switch to go ahead and open up that port because it's now authorized. Unlike our traditional 802.1x authentication, there is no periodic re-authentication with MAC Authentication Bypass. So as long as that camera is connected, there isn't going to be a periodic re-authentication regarding that MAC address. Now if the link goes down and the link comes back up, the authenticator will go through its processes again, whether it's .1x or MAB, trying to authenticate the device that's hanging off of that port. Some of the best practices for security when using MAC Authentication Bypass are to use SourceGuard, which can validate the source IP address. And part of using SourceGuard is to dynamically learn the IP addresses involved. And that would involve DHCP snooping, and we can also use dynamic ARP inspection. And in a secure environment, those are great ideas regardless if we're using MAB or not. When our authenticator, switch number 1, is going through the process of trying .1x, for example, maybe we have .1x listed first, so it tries .1x and then times out and then goes to MAB. It's going to be using a radius service type 6 as it communicates over with the ICE server to let it know, hey, by the way, buddy, this is a MAC address. And depending on your switch, the feature of sending that attribute may be enabled by default or maybe not. So in the demonstration, I will go ahead and enable it. And what I would strongly recommend you do is, based on the type of switch you're using, I would look at the documentation for that specific model and the specific version of software that you're running to make sure you know whether or not you need to enable it, as well as any other 802.1x commands that may be specific to your switch. For the lab, I'm running a 3560 switch. It's got gigabit ports with power over Ethernet for each one of them. And it's running iOS 15.x. So on the authenticator, we can identify the methods that we want to try to authenticate the device hanging off of that port. So we can specify, like, for example, .1x and MAC authentication bypass. We can also specify web authentication. And we can also specify a priority. For example, if the switch is saying, I want to try MAB first, and then I want to try 802.1x, if the authentication is successful with MAB, it won't even go down to 802.1x. But at the same time, if there's a supplicant that's actually sitting off of that port and it sends an EAP message, the switch can say, whoa, this guy's an EAP client. I can go ahead and authenticate him via EAP, and then it can prefer that method for authentication over the MAC authentication bypass. So the point here I want to mention is that we have the order that we can specify on the authenticator of what we want to try for authentication, and it will try those in order. And we can also specify the priority, which implies that we have multiple options that will be successful in working, and if that's the case, which one do we want to prefer and use for the authentication of that port. On port gig 0/7, that's where our supplicant is. Let's go and take a look at the configuration on this switch port with a show run interface gig 0/7. And here are all the commands that we have previously placed on this switch port. One additional item that we're going to add in global configuration is the command radius-server attribute 6 on-4-login-off. This attribute number 6 we're going to use for the authenticator of the switch to let the ICE server know that it's sending over the MAC address of the device being authenticated, and we'll be able to see that in the debugs. What I'd also like to do on interface gig 0/7 is let's assign it to a VLAN, something other than the default of 1. So we'll put it in VLAN 10, we'll go ahead and bring down the port, and then we'll go ahead and bring it up with a no shutdown. Now you'll notice up here earlier that the client who's connected to that port with the supplicant still active, when we changed the VLAN, the 802.1x kicked in and the client re-authenticated. So to verify what that looks like, we could use the command show authentication sessions for interface gig 0/7, and it'll show us the details regarding the authentication on that port. So here it's showing us that the username was Bob. That's what we configured. Its current IP address is now 10.10.0.51. That was assigned via a DHCP server on VLAN 10. And the method that we used for authentication was .1x. Let's make a road trip over to that Windows 7 computer who's currently running the supplicant. So here's that computer, and if we bring up a command prompt and we use the command ipconfig and press enter, so here's the IP address of this host at 10.10.0.51. This other IP address on the wireless interface is the mechanism I'm using just for basic RDP connectivity to this host, so that we can see this computer and work with it regardless of what happens on the 802.1x. If we did a ping, for example, of google.com, that could help us verify that name resolution is working and default gateway is set up and the routing's all working, and that's great. Now if we go to control panel for this computer and we go into the details for 802.1x by going to the properties of that interface, and go to authentication and say, you know what, I don't want to do 802.1x, and we click on OK, and we bounce that port. I'll go ahead and say disable, and then after a moment we'll right click again and enable it. Because we have the authentication open command still on the authenticator port, we're still going to have the basic functionality as we had previously, even though the authentication is going to fail. So you'll notice now on my computer it says, okay, great, I'm connected, there's no problem. This WebAuth label is because this computer gets around quite a bit. That label currently does not have anything to do with our current situation. We will, however, in another video in this course, take a look at web authentication as well as another option in addition to 802.1x and MAC authentication bypass. So if we go back to the command prompt here, and we do a ping of Google, it's still going to work, and that's because even though the 802.1x authentication is failing from the switch perspective, the port is still open because we're still set up for monitor mode. So if we go over to the switch, it's not as happy. We'll use the up arrow key for the show authentication sessions interface gig 0/7. And we just happened to catch it while the .1x authentication was running. And now that it's done, we have messages that it failed. We'll hit the up arrow key again. And in the status, we can see that it failed. And down below, we can identify exactly what failed. In this case, it was .1x that was not successful, that did not successfully authenticate and authorize. But the port's still open because we're in monitor mode. Next, let's do this. Let's go into interface config for gig 0/7, and let's tell that interface to have a little teeny vacation with the shutdown command. And now that it's shut down, if we want to enable the option of using MAC authentication bypass on this interface, all we need to do is tell it. And the way we tell this interface that we want MAC authentication bypass to be an option is with the command MAB for MAC authentication bypass. And then we can specify the order that it should go ahead and try the authentication. So if we say authentication order MAB space .1x, it'll try MAC address authentication bypass first, and then if that times out, doesn't work, it'll then go ahead and try .1x. And in order for MAB to work, we're also going to need to take that MAC address of the potential clients that we want to use MAB with, and we're going to need to take those MAC addresses and create endpoints, identities, inside of ICE so that ICE can recognize those MAC addresses and give the two big thumbs up saying, yes, that one's okay. Now, even though the order that we currently have is MAB first and then .1x, we also have the ability of specifying the priority in the event that somehow both are set up to work and we want, for example, the .1x to be used. If there's a supplicant present, we can set our priority. And you might say, well, Keith, if it runs MAB first and MAB is successful, it may not even run .1x. And that is true, it may not. But what happens if MAB and .1x are enabled on the interface, on the switch port, and then the client with the 802.1x sends an EAP message over? That's going to trigger the .1x process. And so now we have two things we can use for the authorization of that port. Either the MAC authentication bypass or using the .1x credentials. And this priority command says we're going to use the .1x over MAB if they're both present and available. Let's also do a debug of radius authentication so we can see the fireworks as they happen. So debug radius authentication is now enabled. And let's bring up the port with a no shutdown. And they are off to the races. Now if we scroll up just a little bit, you notice it says I'm starting MAC authentication bypass first because that's the order that they were listed in. And this call check is the telltale sign that we're sending the MAC address as the identity over to the ICE server. And here under username, that is literally the MAC address on that PC ending in 5013. Now if we scroll down a little more, it indicates that MAC authentication bypass failed. It was not successful. And the primary reason for that is we have not yet configured that MAC address in ICE as an endpoint, as an identity that the ICE can use to say, yes, that matches. So after failing MAB, it then went into .1x, which also failed because there's no supplicant being run on the client at the moment, because we disabled it at the 802.1x client on the Windows computer. So here at the switch, if we do a show authentication sessions for interface gig 0/7, so here's our command, show authentication sessions for interface gig 0/7. The status is failed, and it also shows us that it tried MAB first, it tried .1x, and they both failed. So let's exit out of the configuration mode for the switch, and let's go over to the ICE server, and we'll take that MAC address of the host, and we'll create that as an endpoint identity that ICE can use for the authentication of that port. So I'm going to https://ice.nuglab.com. I'm not getting a certificate error because between this video and the previous one, I imported the root CA certificate as a trusted CA, the same CA that issued the certificate to the ICE server. So my browser is no longer complaining about the certificate because it can validate it, we're going to log in as admin. Now that we're logged into ICE, let's have ICE tell us about some of the successes or failures regarding clients who've been authenticating. And to do that, we're going to use this option here called Operations. And then from the drop down, we're going to select the link for Authentications. So we'll click Authentications, and it's showing us here that we've had some failed authentications, a successful authentication with Bob, and in fact 4 of them, and then more recently we've had some failures. Now to see the details, there's a column for details here. We can click on this link for details, and it will show us the details of those failures. And here it's saying the endpoint conducted several failed authentications of the same scenario, like he was trying over and over again. And here it shows these steps that it went through. And wow, it did a lot of work on the back end. But if we look at all of these, all the way down, it's probably this one right here that causes us the grief. Subject not found in the applicable identity stores, meaning we don't have a user account or the MAC address currently set up in ICE so that we can validate the MAC address of that PC on that port that's using MAB. So here's the MAC address. So I'm going to cheat just a little bit. I'm going to highlight that, right click, and I'm going to copy that to my clipboard because that's the exact MAC address that we're going to need to create an endpoint. And then down here it's also telling us to check whether the subject is present in any one of the chosen identity stores. And at the moment we're just using our local identity stores. And as we branch out, we can also use Active Directory and LDAP and additional resources as identity stores. So we'll say thank you for this logging information. We'll close that window. And to create that identity inside of ICE, we're going to go to the administration area. So we'll hover here. And from the drop down, there's a section called Identity Management. And we are going to select Identities. So we'll click on the Identities link. Under the Users section, we've got our good buddy Bob, and we also have a section for endpoints, and that's where we're going to add the MAC address that we want to be authorized when MAC authentication bypass is being used. So with endpoints highlighted, we'll go ahead and click on the plus symbol to add a new endpoint. I love it that right here it's telling us the correct format, because MAC addresses could be written as 4 characters, dot 4 more characters, dot 4 more characters, or they could be 2 characters and a colon, 2 more characters and a colon, etc. Or they could be written as 2 characters, a dash, and 2 characters and a dash. It depends on the operating system and how it's supposed to be formatted, and it's telling us right here that it wants 2 characters, a colon, 2 characters, a colon, etc. for the entire 12 characters. So I still have that MAC address on my clipboard, so I'm going to right click and simply paste and put in the perfect MAC address. And I'm not going to assign any specific policy or any specific group. I'm simply going to go ahead and submit it. Now to help this along a little bit, let's go back to the Windows computer. We'll right click on the interface, we'll say disable. It'll lose link. That'll cause this switch port to go down. We'll let it settle for a few seconds. And then we'll right click and say enable, still with the 802.1x disabled on this interface. And what should happen is MAB should kick in. It should have successful authentication. So let's see if that worked. We'll go back to the console. And that looks like it has failed. That's not fun. So see right here it says the MAB for client, and that's the MAC address right there. On interface gig 0/7, that has timed out, it has failed. It went to .1x, and then .1x tried and it failed, and then it's going to go ahead and retry. And now it's retrying MAB, and MAB is failing again. And .1x is started, and .1x is also going to fail because we don't have the supplicant turned on. So it's time to do a little troubleshooting. Let's bring up our ICE interface. Let's go to Operations and go to Authentications and take a look at the details for this authentication which keeps failing. So we'll click on the detailed report again, and if we scroll down to the details, it has the MAC address as the username. has the endpoint ID with that same MAC address. It knows what its IP address is. That looks good. The authentication method is MAB that we're failing on. The network access device is switch 1. The service type of call check is perfect for MAC authentication bypass. The network access device, also called here the network access server, is our switch. There's its IP address. There's the port in question. That's the type of the port. If we scroll down to other attributes, it simply indicates that it doesn't know about that endpoint. So here's what I'd like to do. Let's go ahead and close that detail. We'll go back to administration and we'll go to identities. We'll click on endpoints. There's our MAC address. I'm going to go ahead and select that endpoint and I'm going to delete it and we are going to recreate it. So I'll click on yes, I'm sure, and we'll click on add one more time. So that is the MAC address. I'm sure of it. In fact, if we go back to the PC just for a moment and we go to the command prompt and do an ipconfig/all, here's our MAC address and that looks perfect. I'm going to go ahead and shut down that interface for a moment. We'll come back to him in a little bit. Let's go back to ICE and we'll save that. I just pressed enter to save it. And let's give it another go. So we'll go back to our PC. We'll right click on our interface. We'll enable it and we'll cross our fingers that the MAC authentication bypass will work, because it looks like we have all the pieces in place on the switch, and it indicates based on the logs that the ICE server is simply not seeing that endpoint identity, which we just configured. In fact, we just reconfigured it. So let's go back to the console, and that is still not working. So let's go to the interface. I'm going to shut it down and let's take a look at our config. Let's do a show run, and we'll simply include any output that has the word radius in it. So there's the attribute 6 that we just added. If we scroll up and take a look at our debugs, it shows us here that we're using 25 as well for the service type call check, which is associated with the MAC authentication bypass. And let's do this. Even though it looks like that attribute is included and being used, let's go ahead and add that specifically to the config, because I don't see that here. So we'll go into configuration mode with config T and say radius-server attribute 25 access-request include. And again, based on your flavor of switch, this may or may not be a function that works on its own. Now in troubleshooting, it's really a good idea to make one change and then see if that change has an effect. So now that we made that one change, let's go back into interface gig 0/7. Let's do a no shutdown. The debug is still running, and let's see if that makes a difference. So MAC authentication bypass is starting, and it is failing again. And then it tried .1x, and then .1x failed because our supplicant for 802.1x is currently turned off on the Windows client. And because everything looks good, I think we should go ahead and simply restart ICE. I think this may be an issue where that entity that we just created for some reason isn't fully baked inside of ICE. And because we don't have a whole bunch of users yet that are relying on ICE, in fact we have one port with open authentication. Here on the ICE server, let's go ahead and log on as admin with our password. And while we're at the console, let's do a show application. And I know you can give us more information than that. So let's do a show application version of ICE. And that'll give us more details on the version of ICE that we're running. So we're running 1.2.1.198 with a build date of May in 2014. And it also shows me that it's not currently running any patches. So if there was patches involved, they would also show up here. We can also do a show application status for ICE. And here it's saying that when I built my virtual machine, I should have told it that it had 200 gigs instead of the measly 120 plus gigs that I gave it. And in a virtualized environment with thin provisioning, it wouldn't have mattered because it's only really using as much disk space as it needs, even if it thinks it has a larger hard disk. And while we're here, let's do a show interface. So there's the IP address of our primary interface that we're using at .117. And we can do a show IP route right here as well. And what I might do if the reboot doesn't fix it is I might also take a look at current bugs for this flavor of ICE to see if there's any known reported issues with Mac authentication bypass. So what you and I are going to do, we're going to go ahead and tell this guy to reload. It's asking us if we want to save the running configuration. The default answer is yes if we press enter. And it said, okay, I saved it. Do you want to continue with the reboot? I'm going to say yes. And our ICE server is now entering a reboot cycle. I let about 5 minutes go by, and let's go ahead and try to connect again. So I went to the URL at ice.nuglab.com with HTTPS. I'm now logging in as admin. I'm going to say no to the setup assistant. I'm also going to say please don't ask me about that again by checking that box and clicking no. I do not want to run the setup assistant wizard. And let's go to operations. And under operations, we'll go to authentications and we'll take a look and see if we have had any success since it's rebooted. Hey, woo, look at that. That's great. See this checkbox right here? If we hover over that, it says radius status pass. That's great. If we go to details of that, it's indicating that the authentication succeeded. And over here on the right, the steps it went through logically to get there. It selected an identity source called internal endpoints. It looked up that endpoint with that MAC address, which we supplied. It found it, and it said, congratulations, you pass. And the interesting thing is, I did nothing but reboot that ICE server. And the process for troubleshooting that was to do our debug radius authentication, to look at what the authenticator was sending, to make sure that we had that endpoint configured. And once all those pieces were in place, because we're working with a brand new default configuration on ICE, because it should have worked, that's why the last resort was a reboot of the ICE server. And in my lab environment, perhaps it doesn't have all the resources it wants. So now let's go back to our console on the switch. So if we scroll up and take a look at some of our output, here we have another attempt with MAC authentication bypass. And if we scroll down a little bit, we have this message saying authentication results success from MAC authentication bypass for this client with this MAC address. So now, if we use the up arrow key a couple of times, and we issue the command show authentication sessions for interface gig 0/7, we now have our success status message. And it also indicates the method that was used for that authentication. So MAC authentication bypass was used. Because it was successful with MAB, it didn't go on to the other method. Now, just for grins, if we do a show run for interface gig 0/7, because we said the priority is .1x then MAB, if we went back to that Windows machine and we turned back on 802.1x authentication, that would trigger us sending some EAP messages into the switch. It would trigger the EAP authentication process, and the port would be re-authenticated via 802.1x with our credentials of Bob, instead of the MAC authentication bypass. So I think we should do it. Let's go back to our machine. So on the client, let's go to the interface here. We'll right click on the properties of the Ethernet interface that's connected to gig 0/7. We'll go to properties of that interface. And let's go to authentication. Say yes, we changed our mind. We do want to do 802.1x authentication. We'll go to settings. And at the moment, I'm not validating server certificates, which is fine. We'll configure the selected authentication method. I also want to confirm here I'm not sending my Windows username over. So we'll click OK there. Click OK again. And then the bottom under additional settings for user authentication, we'll click on Save Credentials and we'll put in Bob's credentials. Click on OK. OK once again. And now it says it's attempting to authenticate. It looks like it was successful. So let's go take a look at the console of the switch. So on the switch, the debugs are still running. And once they settle down, check this out. It says authentication results success from .1x. And there we can see that we are sending over the credentials of Bob, and that's because we're preferring .1x over Mac authentication bypass. So now if we hit the up arrow key and issue that command again, show authentication sessions for interface gig 0/7, it says right here that Mac authentication bypass was not run. Now, previously we were in on Mac authentication bypass. So what that implies is that when our client, our Windows 7 machine, sent an EAP message, the switchboard said, okay, Mac authentication bypass, I think you're done because there's an EAP message coming in, we'll go for that. And to confirm that, we could just scroll way the heck up in the output here. So scrolling many pages up, here was our command of show authentication sessions for interface gig 0/7 right after we had authenticated with Mac authentication bypass. And at that point it's saying, okay, MAB is how we authenticated, it was successful, and we didn't bother doing .1x. Check this out. If we scroll down just a teeny bit, the moment the 802.1x client sent an EAP message into the switch port, that triggered a failover from MAB, and it went directly to .1x. And the output of our debug here, we're trying to authenticate as Bob. There is no dash in the word Bob, but somehow my output for debug got mingled with some other content, which is pretty funny because we're making up new names here, new words here as we combine letters in the output. So then if we scroll down, the authentication via .1x was successful, and that's why at the very bottom here it's saying we were successful with .1x, even though it's not the first in our methods. It is, however, the preferred method. And if we disabled the supplicant on the Windows 7 computer and bounced the port and brought it up again, it would try MAB first. It would be successful because we have that endpoint configured. And the .1x attempt wouldn't even have been made. And just because this is so darn fun, let's go ahead and do that just to verify that the behavior is as expected. So back at our Windows client, we'll go to the properties of that interface. We'll go to authentication and say, you know what? I changed my mind. I don't want to do 802.1 authentication. And we'll also bounce the port by disabling the interface. That'll cause the loss of link up at gig 0/7 on the switch port, and then we'll give it a moment and bring it back up. And then if we go back to the console of the switch, it should be attempting MAB, which it is, and that should be successful, which it is. And if we hit the up arrow key and do the show authentication sessions command again, it's indicating successfully that we are being authenticated via MAB, and that it didn't even try .1x. In this video, we've taken a look at using Mac authentication bypass by configuring an identity for the MAC address of a device hanging off of a switch port and telling the authenticator, the switch, that for that port we want to use MAB as one of our authentication methods. We also configured the priority of the authentication so that if we were using Mac authentication bypass but the client started sending EAP messages in, the port would go ahead and do re-authentication attempting to use the 802.1x due to the client triggering that to happen on the port. And we also verify that we could bounce back and forth between 802.1x and MAB to verify that they both work correctly. I have had a great time in this video. Our action items are to lab this up. The more you can practice with the basic concepts of ICE and 802.1x and now Mac authentication bypass, the better you will be at working with those technologies. So again, I've had a great time in this video with you. I hope this has been informative for you, and I'd like to thank you for viewing.